This is the first lecture for Chapter 21, Hydrocarbons. Going to talk about models of atoms, because we're going to be working on a model lab, and a little bit about naming organic molecules. So starting out, what is an organic molecule? Organic molecule is a molecule that has carbon. Not all carbon compounds qualify. CO2 is not really considered to be an organic molecule by most, but the idea here is that most carbon compounds would qualify as organic molecules. Hydrocarbons pretty much all qualify as organic molecules. That would be the simplest molecules that we're going to study in this chapter, and they have hydrogen and carbon. Talking about models, we need to review over the different types of models. You can see that we've got molecular formula, which is actually a model. It's a way to represent a compound. That's just numbers and letters that tell you how many atoms of each type that we have. Structural formula would be letters, sticks, and they basically show you a little bit more about how the molecules put together. A stick represents a shared pair of electrons. Ball and stick model would be the sketch you might make of these ball and stick kits that we put together. And then the space filling model is a little bit more of what it might really look like if you were shrunk down to that size, because it kind of represents the electron clouds. So we're going to look a little bit at dot diagrams, because we will use dot diagrams to represent these models also. Remember that as far as dot diagrams go for elements, the Roman numeral in the A column, 1A has 1 dot, 2A has 2 dots, 3A has 3, and so on. So to do an element dot diagram, you basically just look at that number. When we do dot diagrams for compounds, you're going to take the dot diagram of the element and put it next to the others and share electrons until you can get full orbits. Remember that hydrogen only needs 2 for a full orbit. That's the first orbit. First orbit has 2 electrons. The rest of them, pretty much the rest of the elements, all have 8 electrons when they're full. So practice some of these. Make sure you can do dot diagrams for the organic compounds that we work with. Remember, double bond has 4 shared electrons. Triple bond has 6 shared electrons. And for dot diagrams, we show all the dots, even the ones that aren't shared. There's also a type called a structural dot diagram. You can see on water here that we have sticks for the shared pairs, and we have dots for the unshared pairs. So here's another dot diagram over here, a little bit bigger molecule. It's a structural dot diagram there. All right, so we're going to talk a little bit about the refining process, because a big part of this is, especially since we've had the oil boom down here in Texas, and yes, it's dried up a little bit, but they always come and go. So just be ready, because it'll be back in swing in a couple of years again. Fractional distillation is the process we use to take oil out of the ground and split it into all the products that we need. See that we have a boiler over here that heats water. We put superheated steam into this because you don't want spark anywhere around where the petroleum products are, because they're flammable. So we will take that and we'll heat the different levels. And you can't really see the words real well here, but as you look through the different levels here, the idea is that we will heat the oil, the crude oil, to a certain temperature, and we have gasoline boil off. Gasoline will boil off, it will go out these pipes, and it will be stored somewhere. Once it's all gone, the pressure will drop in that chamber, and we know we move it on to the next chamber. Then we heat it up a little more, and the next product will come off, which might be kerosene. You heat it up to the boiling point of kerosene. All that comes off. When it's done, then the pressure will drop and it's ready to go to the next chamber. And you do it by fractions and increase the temperature each time until you finally get to the point where you're taking off the motor oil that is one of the products that heats to the highest temperature to make it boil off. And some of the stuff that's left is used for asphalt and road products. All right, rating gasoline. When you pull up to the pump, some of you are already driving. Some of you may fill up for your mom or your dad. See that there's choice of 87, 89, 91 octane. This is a rating system, and the formula is a little complex, but the main idea of it is that they're kind of rating, octane is kind of right in the middle where gasoline occurs. The oct means 8 carbons. So it's a rating process that tells you basically the anti-knock component. And on most of the pumps, they actually give you the formula that they use for octane rating. They established this in the 20s because people were selling gas that had all different kinds of requirements. And I'm not much for government regulation, but this is probably a good place for it because you really needed to be able to rely that when you pulled up to a pump that you had some kind of product there that was good for your vehicle and what you were expecting. So we're getting into the kind of the main focus of this chapter. We're not going to do as much with the reactions as you might in a college organic class. We're going to do a lot with naming. So we're going to start out by talking about one of the main categories, and that would be the alkanes. This is a group, and the ending is real important, the A and E ending, because when you see a compound with an A and E ending, that tells you that it's all single bonds. So the alkanes, they are hydrocarbons that have single bonds. We'll use prefixes to tell you how many carbons there are. And these prefixes are always the same prefix. These are the first 8 here. I think you may have more on your paper. Methane, ethane, propane, butane. So methane would be a 1-carbon compound with single bonding. Ethane would be a 2-carbon with single bonding. So you can see how the names are real useful in helping you remember what the actual substance is. So learn these prefixes. They will not be on a possibly useful page or a chart. You'll need to know those, and you'll be using those for doing some of your naming. So here's another chart that kind of takes you through 1, 2, 3, 4, all the way to 10 carbons. Meth, eth, prop would be the prefix. The IUPAC, this is a question on your review. IUPAC is the International Union of Pure and Applied Chemists. They'll be on the last set of notes that we get. So you can see the structure here. Now they're actually using a condensed form of the structure. So look at it real closely. I'm going to draw we'll do propane here. Well, no, actually, let's do butane. So C, H, H, H. H is out here everywhere. If you see the words structural diagram, you have to put all the C's and H's to get full credit. That's a structural diagram. The next step to this would be to shortcut and say CH3 next to CH2. Now notice there's only 2 H's on these because they're not on the end. Next to CH2, next to CH3. That's the condensed form. We also have a form called the condensed, the most condensed form, which will take these and say CH2, 2, or however many there are. And we can't do that with the CH3s because they're not together. But if there are 20 of these, you can see how you could shorten your name, your formula a whole lot. So structural formula, condensed, most condensed. And those are some of the other types of models that we'll use in naming these compounds. So far we kind of hit the easy stuff. Yeah, you have 4 carbons, 1, 2, 3, 4. Butane, boom. That's it. It's but for 4 carbons in A and E. Sometimes we have branches that come off of the main compound. Those are called branch chain alkanes. And there's the next couple of pages, there are the rules, and the rules look pretty complex, but really it's kind of like if you had to write rules for tying your shoes, to somebody who'd never done it, you'd have to write quite a few rules because it's a little tougher to explain all the steps that you have than you might expect. So, the deal with naming the branch chain alkanes, look over the rules, make sure you understand them, but pretty much doing practice is the easiest way for you to understand how to do branch chain alkanes and name them. What we have to do is, I'm going to put the substituent names up here. Just like before, meth is 1, F is 2, prop is 3, but is 4. But when the carbon chain is a side chain, we don't name it ane, we name it YL, so methyl, ethyl, because it is a chain off of the main chain. So, on your review, it asks you what's the ending for side groups of carbon chains, YL. Methyl, ethyl, propyl, butyl. So, in general, the way that we do these, also, we're going to talk about the halogens because that gives us a little bit more to work with as far as groups. If the halogens are a side chain, then we take the I and E ending off, we throw that away and put an O. So one fluorine would be a fluoro, one chlorine would be chloro. And remember that, we'll come back to it here in a minute and make some compounds where you can name those. All right, so these are the rules, and I know when you look at them, it's maybe depressing because there's so many of them. There's a couple pages of those. We're going to go through and do the rules on some of these compounds on the example of branch chain alkanes. Remember also that there are a couple really good pages that have 20 or so practice problems with the structures and the names so that you could go back and forth. You could try the name, see if you could draw the structure correctly, and then check it. You could look at the structure and try to do the name. So you could use those to go either direction. So we're going to start up here on the very top where it says example branch chain alkanes. We'll look at this first one, and we see that we have 1, 2, 3, 4, 5, 6 carbons in the main chain, and then we have some branches off of it. So where we have 6 carbons, and I'm just going to use the skeletal diagram right now so you can see it a little easier. When we do this and you've got all the hydrogens, it clusters it up a little bit. So we've got a carbon here, and on 1, 2, 3, 4, 1, 2, 3, 4, we have 2 carbons here. So here's how we name it. Find the main chain. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Either way on this Y branch, doesn't matter which way you go, the name's going to be the same. Try it at the end and you'll see. So we know we've got 6 carbons and they're all single bonds. So we know that the parent name is a hexane. Which end do we start counting on? Well, if there's no double or triple bonds, look for the closest group. In this case, we've got a methyl on the second carbon. We're going to start from this side. 1, 2, 3, 4, 5, 6. So on the second carbon, we have 1 carbon, which is a methyl group. Side group, so it's methyl. So then we also 1, 2, 3, 4, because we can't change directions in the middle. On the fourth one, we have 2 carbons, a 2-carbon group, which is an ethyl. Alphabetically, we list those, which will be 4 ethyl dash 2 dashes between numbers and letters 2 methyl hexane. So that's the name. 4 ethyl 2 methyl hexane. If we were given the name and you were drawing the compound, always start with the parent, draw 6 carbons, and then just put the groups where the numbers are. The number in front of the groups, that's the address. That's where they live. So 4 ethyl 2 methyl hexane. So look over these. We haven't talked about ring compounds or anything crazy yet. The branch chain alkanes is kind of the main guts of the naming, although we will talk about some ring compounds later. The practice pages are so important here. Look at the rules. Go through and try to follow the rules step by step. Some of the extra points, just the things that are important. First of all, always find the parent chain and write that. Then you're going to locate which way, left or right, to number, find the longest chain. You've got the parent, and then anything you didn't count in the parent chain is a side group. If this were a chlorine instead of 2-methyl, it would be 2-chloro. If it's a carbon group, you just use the meth, eth, prop with the YL to name the group, and you always have a number to tell where the group is. That's the address or the carbon that it lives on. Dashes between numbers and letters, commas between numbers. Let's do one more that's a little further down. We'll do the third one, which is the 2,3,5 trimethyl. That one's a little bit more complicated, and that one is a heptane. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. So numbering right to left, we have a group on number 2. So that would be the first way. Let's see, 2, 3, 5 trimethyl, 2, 3, 5 trimethyl. Fourth carbon, we have a propyl. Okay, so this is how we're going to number that one. Let's see, we've got a carbon group here. We've got 3 carbons here. We have a carbon group here and a carbon group here. This was pretty complicated. Be a little easier for you to do these if if you can go through and do one and then check it out after, and then go back and see where you made mistakes. So we know we're going to number from this side 1, 2, 3, 4, 5, 6, 7. If we numbered this way, 1, 2, 3, 4, 5, 6, 7. We got something kind of strange out here on the end that's not going to be easy to name, so we're going to number across this way. 1, 2, 3, 4, 5, 6, 7. Our groups, on carbon 2, we have a methyl. On carbon 3, we have a methyl. And carbon 5, we have a methyl. If we number the other way, we wouldn't have anything till carbon 3, so we know we're going to go this way because there's a group on carbon 2. Number the way that gives you the lowest group numbers. So over here, we have a methylon 2, a methylon 3, and a methylon 5. We also have 1, 2, 3 carbons on number 4. Our parent chain is 1, 2, 3, 4, 5, 6, 7. So we know this is heptane, and we'll write the parent. And then we'll need to write, methyl and propyl. So we'll put methyl first because methyl comes before P, methyl before P. Even though there's 3 of them and we use trimethyl, you don't count the tri or di. So we've got 2, 3, 5 dash trimethyl. I'm going to give myself some more room here. And then dash 4 propyl heptane. Okay? Really complicated. I know it seems that way, but if you break it down, let's say we were given the name and we had to draw it. First thing is draw the parent. 1, 2, 3, 4, 5, 6, 7. Methyls on 2, there's a carbon. 3, there's a carbon. And 5. And a propyl, prop is 3 carbons. 1, 2, 3 on carbon 4. So go through and look at this. If you need to rewind it, maybe run through it a couple of times. Make sure that you're up to speed, and you could get the naming and the writing. You're going to have both directions on the quiz and the test. You're going to have a compound. You have to write the name, and you'll have a name. You'll have to write the compound. So try this out. That brings us to the end of the notes, and we're going to do some more naming on the second video. So try the practice pages. Do as much as you can on